So we're going to talk today about concavity and points of inflection. And it'll make more sense once we start going through the questions, but just a couple of rules, and they're similar to when we're doing increasing, decreasing, and finding maxes and mins. It's really going to be very similar. The only difference is we're going to be using the second derivative as opposed to the first derivative. All right, so I'm going to go through these rules up here, but I think, again, as we go along with each question, it'll make more sense. So the first rule is if the second derivative is positive, and this would be on a sign chart. So if we find out that the second derivative is positive, then we know that the function would be concave up. Okay, concave up being like this, like a cup. Okay, now if the second derivative is negative, again on a sign chart, then the function would be concave down. Okay, kind of like a frown, like that. And you'll see again as we go through this. Okay, so if we want to find critical points, right, for the first derivative, remember we took the first derivative and we would set it equal to 0, or we would see where it didn't exist. Well, the same thing happens here, is if we want to find the critical points in the second derivative, we would look for where the second derivative is equal to 0, or where the second derivative doesn't exist. Okay, and we're going to find that we have points of inflection, and I'll explain what that is, when the second derivative changes sign. Okay, so let's say we have this graph right here. What I want you to do is take a minute, take a calculator. If you don't have one with you, just kind of share with somebody. And I want you to sketch the graph on this axis right here. Okay, so pause me and do that. Okay, so you may not have exactly what I have here. I'm sure that maybe you didn't put points on there that I did. So maybe you want to add that to your graph, but this is generally what your function should look like. Now, the reason why I put certain points on this graph are the following. So first of all, I know that the graph is hitting the x-axis, so I have a 0 at -3, 0, and at 0, 0. Okay, so I just put those there. Not the best picture in the world, but I've got a maximum here at -2, 16. And then this point here, okay, so this one might have been hard for you. I went honestly to the table. But right here, I want to show you something. If you look at the function, right here until this red point, do you see that the function is concave down? But then at this red point, all of a sudden the graph starts going concave up. So this red point is what we call a point of inflection. That's where the function changes from concave down to concave, in this case, oops, where's my pointer? There we go, concave up. Now, by the way, we could have a point of inflection if we had a function that was concave up. Let's say we started here and it was concave up and then it went to concave down. That's still a point of inflection. Okay, a point of inflection is just where we change concavity. It doesn't matter whether it's going from concave up to concave down or from concave down to concave up. Okay? All right, and so I'm going to show you ways to algebraically find these points. All right, so look at part B. Part B says find the first derivative and make a sign chart. So you're going to do that. And then part C says find the second derivative and make a sign chart. By the way, same rules in part C as part B, nothing changes. So take a few minutes, pause me, work on that. Okay, so let's look at what you have for the first derivative. So here's my first derivative. I set this equal to 0, which would give me this 0. I set this equal to 0, which would give me the -2. You're going to plug in like -3. I always plug it into the factored form. It's just easier. And then maybe -1, I would plug that in here. And then like +1, plug that in here. And then we get positive numbers, negative numbers, and positive numbers. Okay, so just remember this here, because the first derivative changes from positive to negative, we know that the function has a maximum at -2, which you can clearly see that right here. We've got a maximum here. Okay, now at 0, we're changing from negative to positive, which means the function has a minimum, which makes sense right here, correct? All right, now we're just going to do the same exact thing for the second derivative. So I'm going to take the second derivative, okay, that's a double prime, by the way, and I'm going to go and I'm going to take the derivative of 12x squared, which is 24x, plus, and then the derivative of 24x is 24. So I'm going to be taking out a 24 and then I'm going to get x plus 1. So if I set that equal to 0, then the only 0 that I'm going to have there is at -1, and I'm going to call this f double prime. Because now what's going to happen, guys, is you're going to have two sign charts, one for f prime and one for f double prime. That's why it's really important that you label both of these. Okay, if you don't, you lose points, so make sure that you do that. All right, so I'm going to plug in, let's say, like, oops, let me just get rid of that. I'm going to plug in maybe -2, and I'm going to plug it in here. And if I plug in -2 here, I get a negative number, and a negative times 24 is going to be a negative. Okay, and I'm going to do the same thing by plugging in maybe 0, and I'll see that I get a positive. Okay, and so that's how we do sign charts for second derivatives. Same thing as first derivative, right? Okay, so I want you to turn the page, and let's have you look at page 9. Okay, now just read what it says. For each function given, just find the first and second derivative and provide a sign chart. So you're going to turn me off right now. You're going to do that, come back on, check your answers. Okay, so here are your answers for 1 and 2. You can pause me and check because I'm going to move on to 3 and 4. Just check your answers and make sure you're all good. And here are your answers to number 3 and 4. So check those out. If you need to pause me so that you can check, go right ahead, do that, and then turn me back on for the last page. Okay, so for page 10, we're going to do number 5 and 6, and there's a whole list of things that we have to do here. What I want you to see, though, is these first 4 things, increasing, decreasing, maxes and mins. That's not anything different than what you were doing yesterday. We are going to be using the first derivative, okay? And then if you look at those last 3 things right here, those are where we're going to be using the second derivative. Okay, so we're going to apply now all that second derivative stuff that we were just doing. Okay, so take a moment, and what I want you to do is what you did on the last page. Do the first derivative, make a sign chart. Do the second derivative, make a sign chart, and then we can go from there. Okay, so if you look at the derivative, we're going to get negative f minus 2x. And I just factored out a -2 here, got x plus 2. And so then my critical point would be x equals -2. Okay, then I plugged in -3 into here, and I plugged in 0, because I think that's probably the easiest, into here, and I got positive and then a negative. Okay, now I know I didn't write my sentences, but for the sake of space, I didn't write them. So make sure your sentences go as follows. You ready? So in part A, it asks when the function's increasing. So the function is increasing during this interval. Now remember, because the derivative is positive during this interval. That's what you should be writing. Part B asks when the function is decreasing. So I'm decreasing right here. Okay, because the derivative is negative during this interval. Make sure that you have that written down. Okay, then part C asks for maximums. So I have a maximum at x equals -2. And the reason being is because the derivative changes from positive to negative about that point. Okay, make sure you write that. All right, part D, relative minimum, there isn't one. Okay, because there's no sign change from negative to positive. You don't have to say that. You can just say there is no min. That would be sufficient. Okay, so part E, F, and G, those refer to the second derivative. So now I want you to take a minute, pause me. You're going to find your second derivative, set it equal to 0, do your sign chart, and see if you can answer E, F, and G. Alrighty, so then here are your answers. So this was a fun one, right? Now I know some of you were probably like, what? So listen, if you get a constant and that constant is negative, your sign chart is just always going to be negative. Okay, if this was a positive too, then you just have a positive here the whole time. So for part E, are there any points of inflection? No, there aren't, because to have a point of inflection, you have to have a sign change in your second derivative, and you don't. So there's no points of inflection. You can just write none. All right, when is the function concave up? The function's never concave up because your second derivative sign chart doesn't have a plus on it. And when is your function concave down? Always. Or you can say from negative infinity to infinity. Either one of these is fine. And just because the second derivative is negative during this interval. Or if you used this, if you said always, then you would say because the second derivative is always negative. Okay? All right. I'd like you to do the same thing for number 6. Pause me, work on it, come back, check your answers. Okay, now again, just be super careful. I wrote no explanations. You should be. Do not cheat like I did. Okay, so here's my first derivative. I factored it out. So I have x equals 0 as one critical point. I have x equals 2 as the other. So boom, boom. I plugged in points. Okay, I always like to plug them in here. I just think it's easier to get the signs. So boom, boom, boom. So we got positive, negative, positive. Okay, so the first question is asking for when is the function increasing. So here it's increasing, which is that negative infinity to 0, and here at the end, and that's from 2 to 0. Okay, so these are your intervals, and you would say because the derivative is positive during these intervals. That's your explanation. Because the derivative is positive during these intervals. Make sure you write that down. All right, part B wants decreasing. So almost the same, except we're going to be looking just in here between 0 and 2. And again, because the derivative is negative during these intervals. Okay? All right, so then part C, maximum. So maximum is when I go from positive to negative in that first derivative. So that's at x equals 0. Because the derivative changes from positive to negative about that point. Okay, repeat one more time. Okay, because the derivative changes from positive to negative about that point. And part D, we've got a minimum because the derivative changes from negative to positive about that point. Okay, so there's your answer for part D. All right, E wants points of inflection. Well, point of inflection is right here. Point of inflection is whenever there's any sign change. It doesn't matter whether it's negative to positive or if it was from positive to negative. So E, your answer is x equals 1, and you would just simply say because the second derivative, or because there is a sign change in the second derivative about that point. Okay, because there is a sign change at x equals 1 in the second derivative about that point. All right, F, concave up, here we go. 1 to infinity, because the second derivative is positive during that interval. And last one, G, concave down from negative infinity to 1, because the second derivative is negative during that interval. Okay? Okay, so now what you're going to do is you're going to go into Delta Math, and you are going to find the assignment that says Derivative Applications. You're going to work on that. What you don't finish is homework. Now that is due Thursday night. So you have until Thursday night, but I would get started on that now. Okay?